All right, still struggling a little with my camera, but we are going to work today on finding exact value of trig functions in radians. Before we do that, we're going to find reference angles. So we've done reference angles in degrees. Now we're going to find the reference angles in radians. All right. Sorry, just trying to make it work. All right, so the steps to do this, there's going to be two different methods you can use, and you might start with one and switch to the other, depending on how you understand. So I'm going to give you both methods first. Method A, step one, we're going to decide which quadrant it's going to be in. Step two, we're going to draw a triangle. And then step three, we're going to determine the angle. The other way is to convert to degrees. Then determine the reference angle. And then convert back to radians. All right, so this would be a spot to pause the video and copy that down. I'm going to keep going because you have the ability to pause. All right, so example number 1, 3 pi over 4. Now, how do we determine the quadrant? I'm going to do way A first. So to determine the quadrant, I'm going to draw my coordinate plane. But instead of labeling it with degrees, I'm going to label it in radians. So I'm going to put 2 pi here because we know it's 0 also. Pi over 2 and pi, and 3 pi over 2. And now let's think about this logically. And one thing that might be really helpful is it says 3 pi over 4, and that's how we read it. But really what it means is 3/4 of pi. Well, if pi is over here, then wouldn't 3/4 of it be about right there, right? 1/4, that's the second quarter or half, and a third quarter. And we end right there, and so that would be where it is. So this is going to be in quadrant 2. Okay, now we know where it is, and we can draw our triangle. Now the reference angle is the same as it was before, but we want this in radians. So think about it again as quarters. If this is an entire pi to here, and we use 3/4 of it, how much is left? 1/4. So the reference angle is pi over 4, or 1/4 of pi. That's method A. That's the way I like to look at it. To me, it's more interesting. But we are going to do method B now. So for method B, we're going to first convert 3/4 of pi into degrees. Remember, pi goes in the denominator so that we can cancel them out. So we can cancel, and we can divide those. So this ends up being 45, I think. Yes, that would make sense. And then we're going to multiply through. So 3 times 45 is 135 degrees. That is telling us that this angle right here is 135 degrees. So what would our reference angle be? Well, 45 degrees. And that should be pretty familiar from before. But now we want to get this back into radians. So 45 times pi over 180. And again, you can see we're going to follow that same process, pi over 4. So either way, you get the same answer, that the reference angle is pi over 4. All right, I'm going to do one more example for you of how to do this. Let's go with 11 pi over 6. So first we need to determine which quadrant. This is way A. All right, so think about this again. 11 pi over 6 means that each pi is split into 6 pieces. To me, I'm looking at it like this. If this was 12 pi over 6, it would be equal to 2 pi, 12 divided by 6. So we have 11 pieces of it, 11 of those little chunks. And we have 1 left in order to get to 2 pi. So theta hat equals pi over 6. I like looking at it that way. But yesterday in class, a lot of people thought the other way was better. So I'm going to show that way too. We're going to convert 11 pi over 6 into degrees. Pi on the bottom so we can cancel. And then multiply. 11 times 30 is 330 degrees. That's the angle. The reference angle would be 30, right? And hopefully you remember that from before. And then we need to convert 30 into radians. Pi over 6. So the same answer, 2 methods. All right, so that is how you find reference angle. The next thing we need to talk about is how to evaluate the trig functions. And we'll write down the steps. Step 1, determine the quadrant. Determining the quadrant will help us determine the sign, whether it's positive or negative. So you can put that here will help determine positive or negative. Step 2, find the reference angle and convert to degrees. Decide on the sign and write the value. So for example, we want to know the sign of pi over 3. All right, well, where will pi over 3 be? If you need to sketch, do a good sketch. Remember, this is 0 and this is pi. So we want 1/3 of pi. We're going to be about right here. This is going to be in quadrant 1. So that means it's going to be positive. All right. So we're now going to convert pi over 3 to degrees. Pi on the bottom, so they'll cancel. 60 degrees. Well, when you see that, that should make you think, oh yeah, I know that this is a 30, 60, 90 triangle, reference triangle. That means that this is going to be 1, 2, and the square root of 3. Knowing which quadrant helps you know that these will be all positive in this quadrant. And then we want to find the sign of that. So the sign of pi over 3 would be root 3 over 2. Opposite over hypotenuse. That's it. All done. All right, let's do one more example together. Let's do the tangent of 11 pi over 6. All right, so you can draw if you want to. Where is 11 pi over 6 going to be? Well, you might remember from last time, that was almost 2 pi. So 11 pi over 6 would be here, which leaves us with 1 pi over 6 left as our reference angle. We're going to convert, I should probably say in quadrant 4, and tangent in quadrant 4 is going to be negative. Okay, so we're going to convert. the reference angle to 30 degrees. That gives us back our kind of perspective, and that means we're going to have 1, 2, square root 3. The fact that it's in quadrant 4 means that that's going to be negative, and you can see it's going down, so of course that's negative. We want to find the tangent of that. Tangent of 11 pi over 6 is exactly opposite over adjacent, which we need to rationalize, so negative root 3 over 3. And that is how you use radians to find the exact value of a trig function. All right, see ya.